Dear science, your beauty is such that your age is a mystery. We are still trying to figure it out, huh? Actually, have you ever wondered, like, how do we know the age of the universe? We all know that it's estimated to be around 13 or 14 billion years. But how did we come to that number? How did we actually calculate that number? So there are many things that we tried, many interesting things actually. So let's see. We all know that the speed of light is 300,000 meters per second, right? And speed is equal to distance upon time. That means that if an object is far enough, we might not see it in real time. The photons might take longer than real time to reach us, right? So like the sun's rays take 8 minutes to reach our eyes. Actually, in there also, fun fact, electromagnetic visible light radiation is fighting in the solar center through the nuclear fission for hundreds and thousands of years until it reaches the surface of the sun. And then it takes 8 minutes. So it's a story for another day. The point being is that when you look at the night sky in the night, you're not looking at the night sky in real time. You're looking at 1 million years before, 100 million years before, 100 years before, 4.5 years before. Depends on which star you're looking at, obviously. So it's actually a time machine when you're looking at the night sky. And that's a beautiful thing. And that's the important thing that we are going to be using in calculating the age of the universe. So one of the most sure ways to find the age of the universe is to look at the oldest stars. To look at the oldest stars that you can see and calculate the amount of time, the light coming from it, and how much, calculate the distance to it, and calculate how much time the light is taking to reach us. And that's how we calculate the age of the universe, right? That's the oldest star. So, it sounds so simple, but now let's get into it. How do you calculate the distance between a star? But now that's also a very interesting topic, and I'm going to keep it for another time because that's going to take some time. But let's move on to how do we know which stars to look at? How do we know that this is the oldest star or this might be the oldest stars? So let's talk about quasars for a moment. Quasars are very interesting stars. They are supermassive black holes with a gas disk around them, gas and matter and everything, okay? So that disk is known as an accretion disk. It's matter that the black hole is engulfing into itself. So basically, quasars, they emit radio waves. Most quasars, they emit radio waves. That's how we detected them. But their accretion disks, they emit visible and ultraviolet rays. They have jets. They're so cool. They have jets on their poles, which can emit anything from X-rays to gamma rays. And the whole thing just emits radio waves to us because of redshift. Redshift is something that we will explain in another video. So quasars are these huge supermassive black holes who engulf stars at any moment. They are normally present at any galaxy's center, and they engulf stars at any given moment. The stars and the matter and the gas that it's engulfing at any given moment is known as the accretion disk. And this accretion disk can span light days. That's how huge the quasars actually are. So we have a supermassive black hole like this for our galaxy too. And it's like, how many? More than 43 million solar masses. That's how huge it is. And it's still a faint quasar. It's still very faint, and it's very faint to detect. And that's the black hole actually which we took the photograph of in 2018. So quasars are massive. And the huge ironic part of that is that a quasar is a black hole, which means that it cannot be emitting light, but it is one of the most luminous things in the night sky. It is one of the most luminous things in the universe because of the accretion disk, because of the energy that it takes to engulf all of these things. And what do you see? That's why we are using quasars, because they are luminous and they're extremely distant. Because these are supermassive black holes, right? They are at the center of distant galaxies, and sometimes they even are brighter than their host galaxy. They're awesome. This cool galaxies, okay, basically. So what we do is that we can look at these quasars, the centers of these galaxies. And when we look at them and calculate the distance between us and them. And that's the estimated, age of the universe. And that is because, obviously we know that in the Big Bang, everything was together, right? Very, very, very much together. And then it started to expand. And it started to expand. So quasars are known as one of the oldest things in the universe. They are known as one of the most ancient things in the universe. So if they are the most ancient, then they are the most distant. And if they are the most distant, that means calculating their distance will give us an estimation of the age of the universe. And that's how we came to the number of 13.8 or 13 to 14 billion years, give or take. There is another way, which is, let's talk about the expansion of the universe. So in the Big Bang, we were small, and then we were just big. So right now, we all know that the universe is accelerating its expansion. It's not going at a normal, constant rate. It's accelerating. Even if that is true, then what we are doing is, if it's accelerating in this, we can just calculate back in time when it was at a point. Even if we might be wrong, because perhaps the rate of acceleration is also changing. Right now, it might be different then, it might be different in the future. And the reason of why we do not know this is because we do not know why the universe is accelerating. We do not know why the universe is accelerating in expansion. That's where dark energy comes in, because the energy required to expand the whole universe engulfs 97% of all of the energy found in the universe. So we do not understand dark energy. We do not understand all of this acceleration. And that's why we cannot completely, accurately calculate this expansion, as well as go back in time and, contraction and calculate the age of the universe. But these are our best guesses, 2 best guesses. One, look at the oldest stars, which are quasars, calculate the distance. Yeah, there are 2 ways that you can calculate distance. So one is the parallax method, which you might have heard in like 11th grade or something. But the thing is that with the parallax method, when the angles get very, very small, it gets increasingly harder to calculate the distance. And when we are talking about stars, which are very, very distant, the angles are in even micro degrees and microseconds and even milliseconds. It's very, very small. Another thing that we can use to calculate the distance is redshift. So let's talk about that for a second. So when we discovered that the universe was accelerating, it was discovered by Edward Hubble, I believe, by his telescope. So what he was doing was that he was just observing in his telescope, and he realized that when observing a star, a particular galaxy, they are redshifting. What does that mean is that, the electromagnetic spectrum, that purple is the highest energy one and red is the lowest energy one, red thing, in the rainbow scale. And what is happening is that as the light from the galaxy, who is acceleratingly expanding and going away from us, is trying to reach us, the space between us and the galaxy in itself is expanding, which means that the light in itself is expanding. And what it means that if it is expanding, the frequency is decreasing. So if the visible light is red shifting, what it means is that it is shifting towards red frequencies. It becomes of a lower frequency instead of a higher frequency. So this is known as the red shift. And we can calculate the amount of red shift a particular galaxy is going through. And then we can determine, okay, this is the red shift that is happening. That means that this is the rate at which it is going away from us. So then we can calculate, okay, it is at this much distance from us. So that's another way that we can calculate the distance, the distance between quasars and us, and basically determine the age of the universe. What's something that I basically that blew my mind about everything about us was how we have to find it. How there is no obvious answer. How we are really, you can eat food like this, but we are trying to eat food like this. And that's the beauty of our universe, right? It's not spoon feeding anything. Yeah, it's giving us an opportunity to think and to solve. And that was the first video about, how do we know how old is the universe? So, yeah, dear science, your beauty is amazing. Your beauty is timeless. So, don't be afraid to tell us your age. Someday, we might know for sure. Thank you.